In this video we'll look at valid arguments, and in particular we'll be looking at deductive arguments. So I think first we'll define what a deductive argument is. Basically a deductive argument is one that uses logic and follows formal procedures. So first of all, for a deductive argument you have to start with some premises. Or you sometimes could call these axioms or assumptions, but they're things that are taken to be true. So true, for sure. You know they're true. And then you produce some kind of logical argument. And this is pretty vague because it could take many forms, but it does have to employ the standard laws of logic. And then from that argument, starting with the premises through the argument, you get some conclusions. And this is the basic setup of a deductive argument. You start with premises and you use logic to reach some conclusions. So when is a deductive argument valid? We say that a deductive argument is valid when, assuming that the premises are true, and following through this logic, the conclusion must be true. So, in other words, we can say the conclusion must follow, and that's kind of the key word, must follow from the premises, but it's through this logical argument. So it's some part logic and some part art, because the argument has to be constructed, and that's left to the person constructing it. So this is when an argument's valid. I want to give you two examples of standard types of logical arguments, and these date back to the ancient Greeks. So these types of arguments have been around for a long time. One's called Modus Ponens. Modus Ponens. And the basic structure of this argument has three steps. You have two statements P and Q, and you start with the premise P implies Q, and then you add to it the premise P, and then your conclusion, which we draw these three dots that look like a triangle, is Q. So you take for granted P implies Q, and you take for granted that P is true. So putting these both together, you get that Q is true. So this is called modus ponens. And just for an example, let's take a look at what an argument may look like. So here again is an old argument that's been around for a while. All humans are mortal. This could be rephrased as an implication. We could just say, if something is a human, then it is mortal. Socrates is a human. That's our P part. Therefore, Socrates is mortal. Simple as that. It's a modus ponens argument. If it's true that all humans are mortal and we know that Socrates is a human, then given this implication, we know that Socrates must be mortal. Our second argument type is called Modus Tollens. It's going to look very similar, except instead of the conditional statement, we're going to use the contrapositive, which, if you remember from previous videos, is equivalent to the original statement. So the argument structure goes like this. P implies Q is assumed to be true, but then you assume that not Q is true, and your conclusion is not P. And notice this uses the contrapositive. of P implies Q. So if P implies Q is our original statement, then not Q implies not P is the contrapositive. And again, remember that these are equivalent statements. So given that P implies Q is true, we get for free that not Q implies not P is true. So this being true, along with not Q being true, this arrow carries us over here and says not P has to be true as well. So here's an example of one of these traditional type arguments. How about we say all humans are mortal. But now let's talk about Zeus instead of Socrates. Zeus is not mortal. Therefore, Zeus is not a human. Modus Tollens. So if we if we write these in logical syntax, our Modus Ponens looks like this. P implies Q, we take for granted, and P, and we take all this together, then it must be that Q is true. And then Modus Tollens is P implies Q again is true by assumption. Not Q is true by assumption. Then not P must be true. So that's written in our nice, concise, logical syntax. However, maybe some meaning is masked here. And that's all for this video.